This short video is just to remind you that there is no data entry without data errors, so you need to make sure to check for them and correct any errors you would have caught. If you want to learn more about measurement errors, do read Franzosi's 1990 paper Strategies for the Prevention, Detection and Correction of Measurement Error in Data Collected from Textual Sources that appeared in Sociological Methods and Research. Errors indeed slip through in spite of the fact that PCAs has many ways of preventing errors. In fact, if you can prevent errors, there is less need to check and correct them. So for example, in data entry, PCAs will prevent you from entering a string into a field defined as numeric, or even entering into a numeric field a numeric value that falls outside a predefined numeric range, or a date into a date field that falls outside another predefined range. So for example, here we have a numeric value, and if we try to edit its value entering a string value, then PCAs warns you that the value must be numeric. Similarly, suppose that you are entering data in an object taking the information from a specific document, so a document cross-referenced to that object. The object is a child, grandchild, or great-grandchild of a primary complex object, where the primary complex object is the object at your highest level of aggregation, the macro event in the case of grammar of the sample database. Suppose that your primary complex object does not contain the document among its cross-referenced documents. In a hierarchical organization of the grammar, as in the sample database grammar, higher-level objects must have all the cross-references of all lower-level objects. So PCAs will warn you of a potential problem with the document cross-references. When you copy and paste objects, PCAs will automatically check the parent-child compatibility, preventing any mismatch, and the document cross-references compatibility, warning for any mismatch. Finally, in the process of coding, when you quit coding an object without having coded all the required objects, the grammar objects without square brackets around them, PCAs will warn you if you really want to do that. Yet, despite concerted efforts aimed at preventing errors will slip through, and when they do, you want to catch them, either via automatic or manual inspection. PCAs can help you with both approaches. Let's take a look first at PCA's automatic ways of checking for errors. Let's click on the What Next button on the main form, and then go to Data Functions, Data Error Checking, and finally on the Automatic tab. And let's try some of these options. If you click on Checking for dangling records in backends, here's the result. So the form lists a variety of problems with the data. Not necessarily are these errors. Many of these problems are due to the fact that when you delete an object in PCAs for reasons of efficiency, the routine does not automatically delete all the object's children down in cascade. These records are called dangling records without legitimate parent records. To keep the database clean, these records need to be removed by running the appropriate repair routines. Let's now try the routine that checks for any violation of objects requirements, for example objects that are required but are missing under a given parent object. So we can click here. And this is the result. Indeed, there are two records with missing required objects, and the missing objects are listed under this field and are space and time under the complex object circumstances. Okay, one final check, you can try the other options on your own. Click on the label List Simplex and Complex Object with missing document cross-refs right there. And here's the result. There is one object with missing document cross-refs. Notice how the query results form displays the ID of the object, which can be either simplex or complex, and of the parent object, right there, which will always be a complex by definition. If you click on the ID field and then click on the Go To button, PCAs will recognize the ID, and then open this form from which you can open the detailed view form to perform any corrections to the data. Let's now take a look at the type of error checking that requires human inspection. They are found under the Error Checking tab, I/O-SC verification. First, what do I/O and SC stand for? I/O for input versus output, and SC stands for semantic coherence. I/O in data verification requires checking the coded output against a source document. Semantic coherence refers to a fundamental property of any story. It must make sense. It must be coherent. Contrary to the coding scheme design of traditional content analysis, where the output of coding would not necessarily make sense in terms of relation among coding categories, a coding scheme design, or a grammar, that reflects an underlying story grammar of 5 W's plus H, who, what, when, where, and why, plus how, has this important property. The output of coding must possess semantic coherence. The story must make sense. Even a quick reading of the output may reveal a breakdown in data reliability. Clicking on the option Data Verification by Story View Form, right there, PCAs opens a story view form from which you can select a primary complex to be displayed. So don't forget to check your data regularly. And do watch other videos on generating data as story and verifying data as story.